Assalamualaikum warahmatullahi wabarakatuh. Thank you to Dr. Hanija because will be teaching us electrical principle 2 this sem. So today our group will present about the project that's given by Dr. So I will go through the circuit calculation, which is we choose the circuit from the textbooks, and this circuit that we choose, we must find the line current IAA, phase voltage VAB, and the phase current IAC. We assume that the frequency is 60 Hz. So firstly, we must find the inductance for the inductance impedance, which is the formula is 2 pi frequency inductance. So 2 pi 60 and 0.2. So the value we get 75.29. After we find the impedance for the inductance, then we combine the value, which is we had 100 resistor, we combine with 100 resistor, which is 100 plus j 75.29, and the result you get this for the impedance. And as you can see, AB, BC and AC is same value, which is 100 resistor and 0.2 impedance. So after we get this, we know every line is 125.23, 37.012 degree. So after that, we convert delta from star, which is you can see the design of the circuit is delta. So we convert to the star, which is you can see Z1, Z2, Z3. So first we must find the ZTH. ZTPH you can see 0 degree plus 41.744 37.012 degree equal to 42.547 36.201 degree. So we will get the IA by the formula V over ZTPH. So the ZTPH is this 42.547. So we divide by 100. So the 100 divide 42 by 5, 42.547 36.201 degree. So this the formula for find the IAA. So we get the line current AA is 2.35034 negative 36.01 degree ampere. We know when the V peak value and IAA is also in peak value. So the RMS value for V and I is same. So we can see IAA equal to IAB minus ICA. We also reminder IAA equal to IAB plus ICA. So we can say IAB equal to ICA. So this is the degree for three of that. So when we want to find the VA is equal to VA minus IAA multiply R. So the value of VA minus 235434 minus 36.201 degree and multiply by 1, we will get VA is 98.113 0.8106 degree. So it is same goes to the we want to find the VB. So the VB is 98.113 240.181 degree, and VC is 98113 120.81 degree volt. So when we want to find the VAB is equal to VA minus VB, which is VA minus VB, and the answer is 169.64 169.94 30811 degree. So then we must find the IAC. When we find the IAC, it's more easier, which is VA minus VC over ZAC, which is the value is 1.35729376798 degree ampere. That's all. I will go to Jovin to continue the presentation.
Today, I would like to explain the simulation for the circuit. So, for V1, we use the AC phase 0 degree. For V2, AC phase negative 120 degree. For V3, AC phase is 120 degree. So, the estimate for these three AC is 100. So, to make the output file, we use the iprint and vprint. So, iprint is to gain the output for current, and vprint is to gain the output for voltage. So, we run the simulation. Okay, we click at the output file, and we got the first result, which is for the IAC. We gain that 1.357 and negative 66.2 degree ampere for the IAC. Now, this is for the VAB, which is we gain the 169.9, and the degree is 330.8 degree, which is in volt. So that is for VAB, and the next one is for the IAA. So we gain the 2.35 degree with 2.35 and the degree is negative 36.2 ampere. So that's the result for the ISC, VAB and IAA. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Halim, and today I will present about improvements for our project. So, from our project, there are a few improvements that we can do in order to produce a better circuit. So, first, what we can do is by reducing the resistance in wire, because by presence of high resistance, it will reduce the amount of electricity that flow, and some factor that can affect the resistance in wire, such as substance of conductor, diameter of wire, and the length of wire. So therefore, using a low resistance wire is the best options to maximize our electric flow. So next is by design our circuit in minimized power and dynamic consumption. To do, we can reduce the dynamic and static consumption by these factors such as circuit activities, capacitive load, and leakage current. And the third point that we can do is we can control and reduce the temperature of the circuit, because it can make our circuit and component to be overstressed, and it will also affect the efficiency and can cause harm to our component. And lastly, by stack our components so that we can reduce the cost and make the circuit more efficient. So that's all for me. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.
Hi, I'm Lisley. So I will continue the presentation of this project by present the conclusion. So the conclusion of this project is we are able to study the function of delta Y transformer, which is the transformer that is usually used in industrial facility. The second one is we are able to compare between single phase and three phase. What is the difference between this phase, or what is the main function of single phase and what is the main function of three phase. Okay, the third one is we are able to analyze the voltage and current in delta Y transformer. In this part, we are able to find what is phase voltage and line voltage, also phase current and line current. Okay, the number 4 is we are able to use a few methods to solve the circuit given, such as we are able to convert delta to Y connection. Okay, the last one is we are able to stimulate the circuit and get the same result with the calculation. So in this part is we are using the PSpice to stimulate the circuit, and we get the same result with the calculation at the end of the project. Okay, that's all from me. Thank you.